I suppose that could be considered a big beefy computer if this was in fact an all-in-one device. For today's video, we're going to be taking a quick look at a text to 3D model from Roblox, which is a sentence that I never thought in my life I would end up saying, but here we are, and we do have a rather robust and pretty well performing text to 3D model from Roblox, and we're basically just going to jump straight into taking a quick look at the repository, what it takes to actually run it locally, and then we will go ahead and actually get this installed and running on my local machine, which I will list the specs for right in the lower half of this introductory section, I suppose one could say. And past that, I may actually go ahead and try 3D printing some of the objects that get generated in today's video, but overall, it should be a good time, so let's get into it. Here we see the repository aptly named Cube, which is by Roblox, and this came out about a week ago. I didn't see too much coverage about this. I actually found out about it from a newsletter I follow, and I'm wondering if that's perhaps just partially because maybe folks aren't as interested or in the know about models like this as opposed to LLMs and such. But this is really quite cool, and it is a generative AI system for 3D. So first glance and looking at this and a bit of combing over the paper that I did, basically, it seems like they want this to be the foundations for something larger, where as they speak right here, they're developing a foundational model for 3D intelligence that will support applications like scene generation. So right now, this is only generating like a simple object from a text prompt, not an entire scene, but that is actually mentioned in here as well. So it does seem like that is a future direction that this is going to go. And if that is something that could be run on the same system in terms of the VRAM requirements, it would be really actually quite cool to be able to generate an entire scene. I'm not really going to go over this paper too much. It's very technical about like the objects and things like that. However, it is quite cool. Like some of the references in here are actually really quite old. And like right here on page 8, mesh extraction, these referenced works are actually from 98 and 97. So it's just kind of cool to see sometimes how a lot of older work lays the foundations for newer and more high-tech, I suppose, things you could say. Here you can see in the paper some of the actual outputs, and this is really quite impressive. I've used some other like text to 3D models or 3D mesh, Llama 3D mesh. This really does a good job. I zoomed in a bit to show this example because I found this quite interesting, but basically what's going on here is they gave it this object as an input shape, so it can actually look at an object and then derive a text description of what it's seeing. So right here is an example of that, where it gets this input shape right here, and it says it's a modern farming tractor with, and then it describes the tractor. And then what they did is actually put this prompt into the text to object part of the model, and it came out with this. So this is just kind of an interesting example and something that I found kind of cool to mention, where basically it first looked at this shape and then described it this way, and then they tried to almost like reverse engineer the shape that it saw based off of the description that it generated, which is what ended up here. Really kind of neat, and just I like the nice visual example right there, so I wanted to show this. If we scroll up a little, we can see that they chose the language model from Intern VL 2.5-2B as the pre-trained LLM backbone. So there's just some more kind of technical jargon and things like that in the paper here. But with that, we're going to just hop back over to the actual repository. The install is pretty simple actually, and I didn't encounter any issues from it, which is awesome. There's a few examples of things you can do here. Now, in terms of actual hardware requirements, they do list that out right here, which is always nice to see and just very convenient for the end user. So I always appreciate seeing this. We can see that you want to have at least 24 gigabytes of video RAM. However, there is also a listed option here for 16 gigabytes. So if you do have a 16 gigabyte VRAM card, you should be able to run this. However, I have tested it on the 24 and it actually runs very quickly. The shape gets outputted quite fast, which we will see. I don't know if that's a typo. I would think that maybe they meant 3090 there, but I think there's a 16 gig 3080, but don't quote me on that at all. So yeah, with that, we're basically just going to go ahead, and you can see there's some coming soon and things like that. They have some examples, but we're now going to go ahead and just install this locally on our machine and then run it and play with it and get a feel for it. Our first step to install Cube is simply to install this repository in a virtual environment by doing all this. I like to use Conda environments for a lot of my stuff, so I'm just going to go ahead and create one of those right now. And I will use 3.10. I have done that before with this because I always like to test the stuff beforehand, and I didn't encounter any issues using Python 3.10. So with that, we'll just activate that. And once I am in my activated environment, I am just going to basically copy paste this command right here, which will go ahead and clone this and then move into the clone directory and then install the requirements. You can optionally install MeshLab right here. As they say, it's an optional dependency and can be removed by just running pip install -e space period for better compatibility, but mesh simplification will be disabled. So I am just going to install MeshLab as it's listed there, and I didn't have any problems with that. So now that all of the dependencies have been installed, we can see here that there are two side notes, and one of them actually references a step that needs to be taken if you're using a Windows machine. So that does bode well for actually being able to run this on Windows. And in addition to that, the MeshLab here is optional and can be removed, but apparently mesh simplification will be disabled then if you choose to omit the MeshLab portion here. So I did go ahead and just install it with that. Additionally to that, really, our next step is just going to be to go ahead and download the model files from Hugging Face. If we look at them right here, we can see that it's a little over 8 gigabytes worth of files to download, so it will take a decent bit of time depending on network connection. And we are going to download them using the Hugging Face CLI. But I suppose you could just manually go ahead and download them if you wanted to as well. So I'm just going to let this run. It will take probably a few minutes. The model weights have successfully finished downloading in about 7 minutes, and before we go ahead and just jump to the first inference example, I do want to make note that I omitted something that I think was pretty major, and that is right here that they have actually tested this on Apple Silicon M2 through 4 chips. So in addition to actually having something up here about having Windows installed, they do actually also mention Mac as well, based on that they tested it on Apple. And I was reading right here, it also mentioned something about this flag will not work on Mac OS. So if you use one of those platforms, I do have good news for you, and it is nice to see this just seems well documented and nicely kind of widely applicable to different operating systems and system configurations. So with that, our models are successfully downloaded, and we can just basically go ahead and copy paste this into the terminal to get our first shape output. However, I don't like to use default examples, just like the default prompt right there. So I will obviously change the example. All right, so I have slightly changed this prompt to perhaps suit something that I'm a little more interested in, which would be a monster truck. And if we simply just paste this into the terminal and run it, we will get a shape outputted pretty soon. And we'll also be able to keep an eye on VRAM utilization as this actually runs. So it has to warm up and do some fun things. And then we'll just keep an eye on the VRAM utilization. I believe when I tested this earlier, the highest I saw was right there around 22. So it does take up a decent amount of video RAM. However, there are some optimizations to get it down to, I suppose, 16 or so. Now they are post-processing it, and we can see it's basically done now. So that was maybe 20 seconds max, I think. Right here we can see the actual time, but from the process of actually pressing enter there to having the outputted file was rather quick. So now let's just go ahead and actually take a look at this. I do have a program that I installed on here to actually be able to take a peek at these examples, which I will open right now. It is called Exhibit, and it's basically just a simple little 3D viewer. That is something I very much like actually about Microsoft, is on Windows they have a 3D viewer that was really like pretty good. And I mean, this really, look at that. Like this, that's not bad for 20 seconds. I mean, it accurately actually understood where the engine would be in a monster truck. It has like a frame underneath the actual body. I know you might look at this and be like, what the heck is this? Like, it looks like someone's first time playing with Play-Doh, but this really, for a small local text to shape model, this is quite good. I would say it properly did that. Let's see, how did it do with the suspension? All right, so this axle's kind of floating up there, and this axle's floating back there, but I'll give it a pass because I don't know that writing big beefy monster truck was necessarily a good or bad way to help it assist it. But I mean, let's do some more. Sorry, that's probably really like obnoxiously small. Let's take a peek at it that way. All right, let's try some more prompts, and then I will 3D print something that it makes just to see how that goes because it could be entertaining. All right, I really, this is where I get like, I need to remember that I'm making a video for public consumption. I'm going to try something very mundane and simple. We'll just try a vintage laptop, and then we'll see what it comes up with. All right, our vintage laptop has been loaded. Let's take a look. Fortunately, this just remembers where I'd previously opened the file, and since it overwrites the previously generated one, I can just kind of click open. Okay. Not necessarily vintage, but this is very laptop-like. You can see there is an indentation where a keyboard and screen would be. The trackpad is perhaps flush with the actual top casing here as we can't see it, but overall, this is an acceptable generation for a laptop. Maybe not a retro laptop, but I'm not going to knock it for that. So we'll just basically, I'll do this a few more times and then I'll find one that's perhaps suitable to print. All right, I'm sorry, I can't help myself. All right, I wanted to try it with something that's like kind of like bordering on weird, but also staying within the bounds of a publicly consumable video. So I just wrote, "Oh, what a big beefy computer you are," with one of those weird like anime symbols right here. And again, this will test more of its interpretive capabilities, I suppose you could say, because there is no kind of strictly defined output of what you would be talking about here. So we'll maybe get a little bit of insight into the training data and the direction that perhaps was befitting of that. All right, let's check this one out. And then I may test its reverse like capability to actually extract a prompt from a shape instead of this way. Oh, it just made like a CRT. All right, that's big beefy computer you are. I suppose that could be considered a big beefy computer if this was in fact an all-in-one device, so perhaps akin to the iMac G3. I'm now going to try one that I will actually just try to 3D print as well, assuming that it will generate this properly, which I think it will, and it should be pretty easy to print a car without needing many supports or something of that sort. Following that, I do want to try number 2 right here, where essentially, from my understanding, this will basically do something akin to what we saw in the research paper example, where it kind of looks at the mesh first and then deconstructs it and then reconstructs it again from what it saw, but I am not 100% clear on what this actually does. So we'll run it and then we'll kind of take a look at the output. But first, let's take a peek at our newly generated sports car. Ooh, it just made a Bugatti Chiron. This is legitimately like a carbon copy of the... Look, like you're gonna... Well, we know what was in the training data. Look at this. It is the exact replication of that. All right, I don't necessarily want to 3D print this, so let me go ahead and try to give a little more abstractness to this specific prompt. I'll do race car. All right, let's take a look at the race car instead. I'm guessing it's going to look like a Formula 1 car if I... Oh, nope, it didn't. I was totally wrong. This looks like some hill climb sort of car. That's a Nissan GTR. 100%. That's telltale right there. But it's a little more abstract. So I will perhaps try to 3D print this, even though the gaps here and also the spoiler are going to be quite a pain to deal with. All right, so we're now going to try number 2 right here, where it will show us the tokenized indices of the actual mesh. I have just renamed it to racecar.obj, the one that we previously saw generated, because in the event that this does actually try to re-output it based off of what it pulls from it, which again, I'm not 100% clear on what this does. I don't want it to just be overwritten, so we'll see. Okay, so this is the indices shape right here, which we can see is comprehend all of this numerical data and much easier to comprehend the visual data. Okay, so it does. So that is what number 2 right here actually does, is it shows the recovered object right there, where basically it looks at the original one that we had shown, which was the race car one right here, and then it turns it into the indices right here, and then from those it actually reconstructs the object and then outputs it here. So let's take a peek at that, and then suppose we can look at them side by side perhaps. But that is really actually quite neat. Okay, and then recovered mesh. And this is the race car that it remade. And we can see there are actually some subtle differences here. So this is less detailed overall. There is that artifact sitting randomly right there. And the actual front end right here is a bit different. On the previous one, it was more defined. So, okay, we've seen this one. Let's just go ahead and basically look at the original one now, the race car. This is actually kind of funky. I like this. That is not it. So I have to go back to it real quick in outputs, and then so that's pretty neat. You can see this doesn't have the random floating artifact. The grill is slightly more defined here, and it just seems like there's a bit more definition in the rear and things like that. However, I am going to say the reconstructed one is probably going to be way easier to actually 3D print. So I will probably just do that, and then we'll just kind of take a peek at how it looks printed. All right, so I have gone ahead and 3D printed the little race car, and honestly, it's not bad. The curvature and shapes and things like that, I don't know that you'll be able to see, but it's really not bad at all. And I have to say, I'm overall very impressed with this program. It generates these very quickly, and the fact that it can run locally offline within 16 or 24 gigs of video RAM is quite good. Let me take that off. I'm not going to try getting these supports off because it will just be a total disaster, but this is so cool because this is something that just was generated through, like, basically from my video card. And then we printed it. So from the virtual to the physical is quite cool. And also interesting to consider the future ramifications of such a pipeline. Well, with that is really going to conclude the video for today. I hope that this was somewhat educational or entertaining, and overall, I'm very interested in this. I did not think Roblox would make an AI model that I would test. I have never played Roblox. I don't really know too much about it, but obviously it is a pretty identifiable name and very popular. So that's going to wrap it up. If you have any questions, please feel free to let me know, and vroom. No, I'm just kidding. Thanks for watching.